So let's talk about this one a bit. This is the bus schedules. I talked about it before, but I didn't get to the punchline. I got confused, so I wrote it up. So the point is, if you have this list of IDs, 7 departs at timestamp T, this departs 1 minute after it, as you're looking for that time, 2, 3, this is 4 minutes after it, and so on. That's the problem. So the way you combine buses is what I did is I don't work from this kind of data. This is too hard to work with. Instead, I made this data a tuple, the number of the bus and the number of minutes after the first one that I expect it to come. So bus 7 will be what I'll call time 0. Bus 13 is 1 minute later. Bus 19 is 7 minutes later. Bus 59 is 4 minutes later, and so on. This is how I represent it. And now, all I do is I write code that will combine 2 buses. So I'm going to combine 7 and 13. So when you combine 7 and 13, you multiply those together to get the effective time. Now, they arrive correctly at time equals 77. Bus 7 arrives at 77. Bus 13 arrives at 77 plus 1. The combined bus has an ID of 91. That's 7 times 13. And the delay, this one was going to have the correct occurrence happen at 77 seconds after time 0. This one has the is going to repeat at 91. So it's 14 seconds later than that. That's where you get this number. And this is how you make it recursive. All your program does is combine the first 2 into 1. And then you just call it over and over. And you could even just make a for loop and call it over and over until there's only 1 on the list, or you can put it in the function itself. And if you look at the Fibonacci example, you can see how to do that. I think that was chapter 3 or chapter 2. Let's take a look at chapter 3. Yeah, this has recursion. So here's the Fibonacci. Yep, that's it. So you test to see if you're done. Otherwise, you call it again. So this would be test to see if you're done. Otherwise, combine the first 2 buses and call the same function again on the shorter list where the first 2 buses are combined. It'll look just like this here. That's the trick. That's how you do it with recursion. And we'll hit recursion a lot in the later projects. This really is one of the fundamental important techniques to use.
What you were talking about with tuples, so that's what, that was a method that I was initially going to try. One of the big mistakes I made were I thought I would only save, I would use a list of integers and then find a way to mix them with tuples, if that makes any sense.
Yeah, well, I made a list of tuples. You could make a list of lists, but anyway, this worked. This, boiling it down to this kind of data, made it easy to understand how you're making the problem smaller. After this, the list is smaller. It's only got 4 elements. Right. And so next time it'll 3, 2, and eventually it's 1, and then the answer is trivial. That's the idea. So I'm going to stop this recording.